Chibi 464 works differently than conventional labs. Instead of being given a specific protocol or experiment, students are assigned a particular piece of equipment and provided with a problem statement. Students are then responsible for designing and implementing a multi-week experimental plan where they're going to do the experiments they want, to collect the data that they decide in the way that they wish, in order to be able to analyze it and reach conclusions to address that problem statement. With the COVID-19 pandemic, we've had to adjust like everyone else. So the course design has changed a little bit, but we've kept the core of that student-driven exploration of a particular topic or tackling of a challenge. In the course during this last year, TAs acted as process operators or lab technicians and were here in the lab in person implementing the experimental instructions provided by the students. What you're going to see in this video is an example of a TA working with students to implement a particular experimental plan. They are using a three-phase reactor in which gas phase and liquid phase reactants are coming into contact with a solid catalyst. They are producing cumene, an important chemical intermediate and industrial solvent.
In the beginning, when Gabriel first announced how the lab would be, I did have my concerns, and I think everyone did, just because the biggest part of being in the lab is being in the lab and trying to work things out in person and learn. In fourth year, the focus is more on problem solving, troubleshooting, and thinking about how to design the lab and making it work. But overall, I think that it has been extremely well done, and at least I don't have any complaints. It has exceeded all my expectations, and the academic part of it in terms of how much we're learning and how applicable this class is for real life and finding jobs, I think it's been just a great experience overall.
The reaction that we're studying is a very, classic reaction to be studied in a trickle bed reactor. That is the hydrogenation of alpha-methylstyrene to produce cumene. Our main objective is to try to understand and play around with the flow rates that give us hopefully the highest yield and highest production rate of cumene.
So this is the main setup that we have for this experiment. We have different equipments. For example, we have the main reactor in this part. We have a set of flow meters. We have a pump. We have heat exchangers and the main feed tank. This is the reactor itself. This small part is where we have all the catalysts. The hydrogen and AMS will react on the surface of these catalysts. And for example, for these experiments, students have to change some parameters, for example, the flow rate of hydrogen and the flow rate of AMS to find the optimum situation for their reactions. Based on the notes that I'm getting from the students, I will set the flow rates, the temperature, and for example, for the flow rates, I have to work with the parameters on the pump and also the flow rate of the gas using the valves that I have here.
Our initial point of contact with our TA, who's Mike, was through email. And once we got that going, we kind of met through Zoom a couple of times, got some introductions through Zoom, got to know him a little bit and asked about the setup as well while he was in the lab. So he kind of did a little tour of the setup for the lab on Zoom. And then in terms of data, he usually sends us the data that he's collected throughout each lab session on email. But he also sends us kind of live updates of the lab itself through WhatsApp. He'll send us pictures of, for example, the GC results that we get, or he'll also sometimes take videos of the setup itself, or we'll ask him to take pictures of certain things. So he'll send those kinds of things on WhatsApp, since it's kind of like a live thing that we'd like, but the data itself is usually sent at the very end of the day through email.
Although the most important aspect of the laboratory course is the hands-on experience, this new format that we are using here can meet another skill set that is required from engineers. Many chemical engineers who are working in a large company may have to work with research facilities that are located in another city or even another country. It is an important skill set to be able to employ technology for managing projects remotely. Here, students learn exactly that. Many students are in other cities or even other continents like Asia, and they are learning how to manage projects and solve challenges remotely.
I actually think that's one of the hidden benefits of this online school experience, that we got introduced to Zoom, and it was normalized that it's okay to have a video meeting rather than in-person meeting, and it just made things a lot more efficient, just because now you don't have to walk 20 minutes to the same classroom just to discuss one data point. You can just hop on a Zoom call and do it, which is way better.
I think like something that's been challenging with going online is that sometimes not everyone is in the same time zone. So we thought it would be like kind of a struggle to communicate or meet with each other, but because we kind of know each other's schedules very well, we've found a schedule that works for all of us, which has been great.
I'm very lucky, honestly, to be working with such incredible people that are very sensitive to, making sure that our meeting schedule, aligns with my sleeping schedule and that I can get, a good sleep. So it's really important. That's why being able to, I think, choose the people that you work with in the team, that's been a really great benefit of this lab. So I love you.